For today's lesson, 10-1, or 8-1, we have, again, this chapter we talk about, again, proportions, but the main thing in this chapter, we start talking about the trigonometry that's involved in right triangles, all right? And there are special relationships in right triangles, all right? Now, today, they title it the geometric mean, all right? And I am not going to show you in the right triangles exactly the way they do it. They want you to learn something called the geometric mean. And the geometric mean is just simply the square root of the product of the numbers. All right. Now, the reason why they show it that way is because it's set up as a proportion. All right. And again, I haven't seen anybody ask on a standardized test what the geometric mean. I have seen on standardized tests and geometry tests to figure out the different lengths to the sides. All right. So probably on the test, there'll be just one question to say, what is the geometric mean? So again, the geometric mean is simply the product of the two numbers, and then you take the square root of it. All right. So in this particular case, we're going to say it's the square root of 8 times 12. All right. Now, a quick review of breaking down a square root is you're going to pull common factors out. All right. So instead of multiplying 8 times 12 and get 96 and then breaking 96 down, it's much better if you say there is a common 4, all right, in 8 and 12. All right. So you should be able to look at that and just say the answer is 4 radical 6. You okay with that? Because again, 8 is 4 times 2, and 12 is 4 times 3. So you pull out the 4, and the 2 and the 3 is left behind. All right, so they're okay with that? All right. So again, if I'm looking at, for example, question number 2, all right, it would be the square root of 3 times 15, which I just want everybody to say is what? 3 radical 5. All right. There's no reason to multiply them together and then break them down. All right. So question number 3, square root of 4/5 times 2, and the square root of 4 is what? 2. So I have 2 times the square root of 2/5. All right. The square root of 4, let's talk about that. The square root of 4 is what? 2. That's where that comes from. And then 2 times 1/5 is 2/5. Now, we don't leave radicals in the denominator. We don't leave radicals in the denominator. So we're going to leave that as 2 times the square root of 2 over the square root of 5. It's called rationalizing the denominator. So you change it from an irrational to a rational. So to get rid of the square root of 5, we simply multiply the top and bottom by the square root of 5. 2 radical 10 over 5. Now the question is, can you reduce the 10 and the 5? And the answer was no, because one is rational and one is irrational. All right, you can't reduce unless they're both rational or they're both irrational. Yes?
So, like, if I were to put 14,
I'm not sure.
like
what do you, I mean, how about this? How about instead of telling me your answer, how about you look at mine and you say, what in the world did you do? All right? Because I have no idea where 14, I don't have any idea what you did. And I'm just saying, follow me. So where is it that I added?
I'm saying that if I were to put that, like I understand how you did it, but I'm saying if I were to put that, would be wrong.
Is your answer 2 radical 10 over 5? then your answer is what? There you go. Let me just make that clear. You with me on this? Now my question is, I understand, but listen, the only reason I'm doing this is because in the past I've just crossed this out, and then I realized when I start the algebra 2, everybody forgets the radicals. So the only reason I'm doing this is just to review with you the radicals, that's all. All right? Because you are going to see that on the standardized test, 100% sure. So that's what I'm saying. This is a great review of radicals. So I want to help you with where you made your mistake at. But my question is, or my concern, is that I just want you to follow. Like she said, how did you get the 2? And so I just said, well, the square root of 4 is 2. And she said, okay. Right, so I want to know from this step to this step, is there a problem? And then we went from here to here. You see what I'm saying? I'm trying to correct your mistake. That's all I'm trying to do. Right, but because it's a review, I would not just do what you think is correct. Listen to what I'm saying, and that should refresh in your brain what we did last year in radicals. You went down this. Right, so if you're not sure, I want to know. Right, again, I'm trying to tell you, I always try to teach you the logical way and the easiest way. Right, to me, that's completely logical. Now most kids don't understand why I'm multiplying by a radical 5 over a radical 5, so that's a good question. All right, so the reason why we're doing that is because a long time ago, the mathematicians got together and said, we just don't want irrational numbers in the denominator. Remember, irrational just means a number that can't be written as a fraction. So the square root of 5 is not allowed in the denominator. So to get rid of it, they multiply the top and bottom by the radical 5, and that eliminates the radical from the denominator. All right? Yes.
Is it 2 radical 2 over 5 or 2 radical 2 over 5? It's like, is the 2 in the denominator or not? Or
okay. Are you talking about this right here? Shh. Are you talking about that right? So that is 2 times the square root of 2 over the square root of 5, which is the same as 2 radical 2 over 5, because you can make 2 over 1. Good. Okay, so let me say it one more time. What's the square root of 4? All right, so what I did was, watch this. I took this out. And when I took that out, it became a what? You with me? Shh, just let me get it through his head. So far, does that make sense? So what do you think is, what number is left here? You with me now? And then 1 times 2 is what? Good? I'm listening.
So the other problem is find a common.
Because why? Right. And now what I wanted to say was there were 2 3s. So essentially, look. I'm not. So the original problem was the square root of 4/5 times 2. Now I'm trying to figure out what you're doing different. It's the same thing. True? I mean, if I ask you why did I do it? Why did I just pull out the square root of 4? It's automatically 2. So what you're saying is, here's what you're asking me. 2 times 2 times 2, that's what that breaks down. 4 is 2 times 2, right? That's what. So what you did was you said, well, instead of using this 4, I want to use this 2 and this 2. Right? That's what I'm trying to say. All right, so again, what I'm saying is you're not wrong. It's just when I see the square root of 4, I automatically put what? 2 down. There's no reason to break it down. Right? If it's a perfect square, there's no reason to break it down. That's what I'm trying to make sure you know. All right. Anybody else have any questions? All right. So now we'll get into the important details now. All right. So basically what this boils down to is, please look and make sure you're hearing me, that TUV is a right triangle. All right. Now, what they're going to do is we are going to draw the altitude, all right, which creates another what? Creates actually how many? 2 more right triangles. And what's probably true about all those right triangles? They're not equal, they are similar. All right? Now, what I want to do is, I want to try to explain quickly why that has to be true. All right? Because some kids aren't exactly sure why that's true. So let's everybody take a look up here for a quick second. All right? Now, again, I don't mean to confuse you, but it's easier to see, in my opinion, if they had numbers. All right? So I'm just going to say this angle over here looks like 20 degrees, and this angle over here looks like 70 degrees. Everybody see with me? Everybody see that? There you go, because those 2 angles have to add up to 90. So now, if this angle right here, please watch, because I think this is the key. If that angle is 20, then this angle right here now has to be what? 70. Very good. Brilliant. All right? This one right here now is 70 degrees. Everybody see that? And now the other one then forces that to be what? 20 degrees. All right? So now, does everybody understand now quickly why they have to obviously now be what? Similar. Because we said it's just as long as 2 angles are congruent, then the triangles are automatically similar. Is everybody happy with that explanation? All right? So it's not obvious until you put in numbers. Does it matter what numbers I put in? No, it makes no difference. If I wanted to make it 40 and 50, it would work out to be exactly the same. Now, of course, the angles are different, but it's just the fact that you have to show that they are what? That they are similar. All right, is everybody okay with that? All right. So now, what I want to do is I want to leave those numbers there because you're supposed to write the similarity statement, which just basically means let's write the large triangle first. So the large triangle we're going to call triangle UTV. Am I with me? UTV is similar to, now we're going to go with the medium triangle. Now notice I started U with the what? The right angle. Did I agree with that? So on the medium-sized triangle, you would start with letter what? A. Now, here's the way I like to do it for kids. T represents the what? 70-degree angle. So now the 70-degree angle has to come next, which is U, and then what? U, and then V. Does everybody see how simple that is? All right? Now, it's similar. Now we have to do the small one. All right? What letter are we going to start with? A, and then T, and then U. I think that's really simple. All right. Does everybody understand how writing the angles is very helpful? You with me? Yeah, I just go big and small, but you don't have to do it that way. You can do small, large, or just as long as they're in there. All right. Now, and they have to be. So that means that UT corresponds to AU and AT. Yes. All right. Now, the next observation I want you to do is this. All right? And this is the important one. All right? I want everybody to look up now. And I want you to be able to tell me that that is the hypotenuse. Does everybody remember that? Opposite the 90-degree angle is always the hypotenuse. All right? Now, this right here, I want you to write is the short leg. We're going to get to that. Please write that down for now. All I'm doing is I'm looking at the big triangle. And then over here, this is referred to as the what? The long leg. All right, this is very helpful. Very helpful. And these, like I said, are specifically on the SATs all the time. All right, now I'm going to go to the middle triangle. All right, on the middle triangle, this is the what? Hypotenuse. This is the long leg, and this is the short leg. Now, why is this hard for kids? Because the long leg is also the what? Hypotenuse. Everybody see that? So you have to understand what triangle you're talking about. Now, if I'm looking at the small triangle, this could be the what? Hypotenuse. This is the short leg. And this is the what? Long leg. So does everybody see what I'm getting at here? All right. The hypotenuse, I could tell you, if I said, what's the hypotenuse, you'd have to say, to what? What triangle are you talking about? Because there's how many hypotenuses?
3.
Yes, there are 3 hypoteni. All right. There are 3 hypoteni. All right. So, again, all we're doing is we're solving proportions. That's all we're doing. It's very simple. Very, very simple. But again, setting up the similarity statement is what seems to be hard. So I gave you 2 choices. All right, you can do it by angles or you can do it by sides. All right. So now what I want to do is I want to go over to question number 5. All right. And let's see if we can do the similarity statement. All right. Personally, I always start with the large one first. So I'm just going to write triangle JLK. And the reason why I'm not starting with the right angle is because I want to show you it doesn't matter. All right, it doesn't matter. All right. Now, in this particular case, JL is the short leg. Does everybody agree with that?
Yes.
So now I want similar to, we're going to the middle triangle, and we're going to say, what does that correspond to?
Wait.
Now, be careful now, because I'm going from J to the right angle.
Wait, why is
Just listen for a second. I started with JL. All right, so JL is the small leg. Does everybody agree? So now I'm going to the middle triangle, and I'm trying to find the middle leg. The middle leg, or the small leg, is obviously ML, but it could also be what? LM. So you have to identify I'm going to the right angle. So it would be what? LM. And then once you establish that it's LM, then it must be what? LMK. Go ahead.
Explain why it's LM.
Okay, so look right here. Look how simple this is. All right, I said JL, right? So I have to go from J down to L and going down to the right angle. You with me? So I'm either going to the right angle or going away from the right angle. So I'm going towards the right angle. So if I'm going towards the right angle, it would be going this direction.
Okay, but, okay, I understand.
You with me? All right, now that was the middle triangle. Now I've got to start and do the small triangle. So here we go. Similar to triangle. Now I want the small leg, which is JM, but it could also be MJ. But it's going to the right angle, so it would be what? JML. I just think that's super easy, guys. Super easy. All right. And again, for some people, if that's confusing, I personally like just putting numbers in if you're having trouble. Does everybody understand that? And what I mean by that is, again, if it were me, I would just say that looks like 30, so that has to be 60, so this has to be 60, and that has to be 30. And then I can do it by the angles quicker. Does everybody see what I just did? All right, that's kind of important. All right, yes, sir.
If there's a triangle with it's like an isosceles triangle with a 90-degree angle.
Yeah,
and then
we're going to
two
talk about that.
45s,
Yeah, that means they're all the same.
And what
The two triangles are cut in half, but let me get to that. That's a good observation.
equilateral?
Well, equilateral is not isosceles. I mean, it's not a right angle.
Oh yeah.
That's okay. All right, good question. All right, so everybody look here. All right, so you're supposed to be able to figure out quickly what X, Y, and Z are. All right. Now, what we have here, all right, is I'm going to try to figure out what X is. All right. So to figure out what X is, I need to have two sides of the triangle. So what exactly do I mean? X and 8 are two sides to the small triangle. Do you hear that? Yeah. Now, please watch. So if I say X over 8, I know this is the short leg and this is the what? Long leg. Is anybody with me on that?
Which triangle?
What do you think? Come on now. You see what I'm saying, right? Put your hand down for a second. Let me explain something. All right. Now, what I'm going to do now is I'm going to say, would it make sense to use the big triangle or should I use the middle triangle? If I use the large triangle, I'm going to have Y and Z involved and there's no way to solve the proportion. Everybody with me? So I want to use the middle one because now on the middle one, what is the long leg? What's the long leg? 23. And what's the short leg? X. Is everybody with me on this? All right, so I always teach kids short leg to long leg to hypotenuse. You have to set it up as a relationship between those. All right, if you try to set it up any other way, there's going to be what? Multiple variables involved. And you can't solve an equation with multiple variables. Now, please let me finish. I promise you guys, I'll get to you, I promise. All right? So here we go. So now to solve this proportion, we're just going x squared equals 8 times 23. Notice I'm not multiplying 8 times 23. Right, because I'm taking the square root of both sides. So x is equal to 2 radical 46. Now how did I get 2 radical 46? Because I knew 8 broke down to 4 times 2. And the square root of 4 becomes 2. 2 times 23 is 46. Yes, exactly right. But again, that's why to me it's not necessary to say it's a geometric mean. All right? If it was important to know that, I would make a bigger deal. But no one on a standardized test is going to ask you about the geometric mean. All right. What?
Why was X?
You can make it 8 over X. It doesn't matter. All right. It doesn't matter how you set up the proportion. What?
How do you know which one's the short leg and which one's the long leg?
Visual. Visual.
Or what if it's like you
Well,
said
the
something?
I know. Stop. Listen. Sometimes visually it's not going to work because it may look like 45 and 45, but if it's 45 and 45, that means the triangles are congruent. You with me on this? And we're going to get to that. I promise you. But right now, I can obviously see what's small and what's larger. I'm looking at my problems over here going, they don't really give me any that I can't tell. So listen, if you get to a situation you're going, man, I don't know if that's short or long, then I would say you should plug in numbers. You understand what I'm saying? Because if I made this 40, this would be 50, this would be 40, this would be 50. You see what I'm saying? And then you can see exactly what goes with what. Does that make sense? All right, but honestly, on the exam, it's going to be obvious. It's going to be obvious.
Sorry, I confused myself with a question.
That's all right. Come on.
Why is X the long leg when it's short leg?
No. Listen. It's the different triangles. That's what I tried to show you earlier. I tried to show you earlier that a short leg to one triangle could be the long leg of the other triangle.
But isn't it still why? Okay,
So I did, please listen, 8 is short and x is long. You agree with that or not?
No, why is X long?
Because I'm talking about this triangle right here.
I know, but then you have a 90-degree angle, which would make Y more than
I
X.
didn't say the hypotenuse.
I understand that, but if you're going by the angles, then wouldn't that make Y longer than X?
Y is the hypotenuse. Y is not in the conversation.
Oh, okay.
8 is the short leg, X is the long leg. Now, again, you have to, when you're talking, that's why I'm trying to make sure you understand what I'm saying as far as you have to understand what triangle I'm talking about. All right, you have to understand what triangle I'm talking about. All right, that's what makes it confusing. And we went back earlier, and that's why I made this. I tried to set question number 4 up to show you that just because I say the long leg doesn't mean you know what triangle I'm talking about. Does that make sense? Right? You have to be clear, what triangle am I talking about? All right? So now that I have x, all right, so let me erase all this. And x now we said was 2 radical 46. All right? Now, I want this. Please watch. Hypotenuse to short leg. So I'm going to go y over 8 is equal to, now notice I'm putting hypotenuse to, hold up, hypotenuse to short leg.
So that'd be 23 over Y.
Now, again, there's lots of ways to look at this. So, do you want to look at the middle triangle or do you want to look at the large triangle? And does it matter? No. All right, so if we use the large, the hypotenuse would be what?
23.
No.
31.
31. 31 over the short leg, which would be what? Y. Exactly. Does everybody hear me on this?
So then you don't do 31 times 8, you do the same thing. You do Y squared equals square root of Y squared.
Y squared equals 8 times 31. So y equals the square root of 8 times 31, which is the same as 2 radical
62.
62. Go ahead.
Okay, I have to ask where you got
8 plus 23.
Why then?
Because that's the hypotenuse of a large
Oh,
triangle.
you're doing the large.
Oh, you're doing the biggest.
Yes.
Oh, okay.
So
I was
Now,
thinking the larger
if you use the middle triangle, it would come out to be the same. It would come out to be the same. It doesn't matter, I promise you. All right? So now we have y. Now I'm going to find what? Z. So, now look what I'm doing here, please. Z over 23. So what is Z?
Long leg over.
What is Z?
Oh, hypotenuse over long.
Good job. Hypotenuse over long leg.
Oh, you do that.
Of the short.
Right? Now, with Z and 23, that is the only possibility. Do you agree? Because 23 is not part of the large triangle. Listen to what I'm just saying now. I promise. Come on. So now, hypotenuse over long leg. I don't care what hypotenuse and long leg.
The other one's not the
Okay, so what is the hypotenuse?
It's 31.
2 radical.
Over the...
Z.
Very good.
So then you have to take square root of 23 and
Yeah, so can that break down?
31.
No, it doesn't. So you would just say Z squared equals 23 times 31. So Z is equal to the square root of 23 times 31, which is 690, what is that, 713? Is that right? Somebody do that real quick because I may have made a mistake. 23 times 713. All right. Z is the square root of 713. All right. Now, again, listen. Every single time, all right, you're setting up, in my opinion, hypotenuse to a short leg to a long leg. Those are your options. All right, and I'm going to do one more. Let's go, quick, come on.
I don't understand how you got 62. Like,
Okay, so look, 8 is 4 times 2. The square root of 4. 2 times 31. Okay, good. All right, here we go for question number 7. All right, now, right off the bat, here's what I need. All right, listen, you guys, I just want to tell you. The objective is to make an A. That's what the objective is. And I sent out everybody's grade before Christmas break, and I had some parents who were mad. I had some parents who were mad that they got a 92 on a test. All right? So, again, all I'm saying for your benefit, I have to explain that to your parents. And when they say, why did he make a 92 on the exam? I'm going to say, because they don't pay attention 100% of the time. I'm never lying to your parents. So when your parents ask me a question, I say, well, you interrupt, you giggle, you're doing kid things. You're allowed to do kid things. All right, but I'm telling you, your parents ask me the questions. And I say, are you paying attention 100% of the time? They'll ask me that, and I'll say no. You're not. All right, I understand what you're going through. So you got to help me out. All right, if you want a better grade, you got to focus more. It's not too difficult. You got to focus more, some of you. And some of you are bothering other people who are trying to focus more. All right, and if you're one of those kids who's trying to focus more and you're not allowed to focus because the clown sitting next to you won't let you focus, you need to move. All right, that's just simple. And I'm not a babysitter, and I've told you that. All right, y'all are doing great. I don't have any complaints. If you make a B, that's great. 8th grade B in geometry is amazing. Absolutely amazing. All right, so I have no complaints. But your parents did email me. And I have to give them a full detailed report of why you're in the position you're in. And I'm always honest. All right, so keep that in mind. All right, now let's figure this out. Number 7, the first thing I notice right here is a 19. And some of you asked me how I got 19. Some of you asked me how I got 23. Now you understand how I got 19, correct? Exactly. Exactly. Now, to me, this right here is the easiest one. I want you to listen to me. That is a proportion with the legs. And what do I mean by that? Look right here. The 19 and the 6. Everybody with me? So your proportion is always going to have x in the opposite corners. So it's going to be x over 6 is equal to 19 over x. That's exactly right. Or you can remember what I just said. The variable is always in the opposite corner. All right? But again, let's set up what he said. X over 6, long leg to short leg. Long leg to short leg. Does everybody agree with that? All right. So now we're going x squared equals 6 times 19. There's really nothing we can do there, correct? So we have x is equal to the square root of...
Yeah, but 6 can be 2 radical 2.
2 radical.
2 radical
114.
You're all right. 114. X is the square root of 114. Everybody okay with that? All right. So now I'm going to figure out what y is. So I'm going to say 6 over y. So 6 is a what? Short leg over hypotenuse.
So you could do x over z.
Yes, that's no. Listen to me. No. Again, that is perfect. You can do x over z, but is that helpful? No. So that's good. All right. So you just try triangles until you find one that works. All right. So we can't use the middle, so now we have to use the large. So is equal to what?
Y over 25.
Y over 25. Everybody happy with that? All right. So now I have what? y squared equals 6 times 25, so y is equal to 5 radical 6. Perfect. Everybody good with that?
Is it always going to be a rad?
Not always. Most of the
Can
time,
you
yes.
just,
Sure. Come on.
So what did you do?
Do you understand? Now, again, you asked me, so I'm just saying, do you understand this?
No, what is that?
Okay, so that's the proportion. So all I did, I randomly said I'm going to solve for y now. So I don't want to do y over x because I don't feel like doing the square root of 114. So I just y over 6. Right? And y is a hypotenuse and 6 is a short leg. So then I found a hypotenuse and a short leg of another triangle. And I can't use the middle triangle because there's 2 variables. All right, so now I'm looking for what? So we can say z over 19.
So long leg,
Hypotenuse over long leg equals.
y over.
Well, yeah, we have y. We have 5 radical 6. Or we could do 25 over z. Thank you very much. I think that's the easiest. Do you agree?
Sure.
Right. And again, it doesn't matter if you use the other one. It'll be the
But
same
it's
answer.
easier to not
It's easier to not use the radical. So in this case, we have z squared equals. Yeah, so now you guys have reviewed 5 radical 19. The radicals are not. No, because listen to your mistake. Your mistake, right, the whole radical 25. All right, here we go. So let's try 8 now. You should be good. All right. So let's solve for x first. Solve for x. So 3 over x is equal to, so again, this is long leg to short leg. So then, wait a minute now. Long leg would be 3 over 2. Is everybody good? Is that what you said? Yeah, I did write that backwards. Thank you. So that's right. So this would have been 3 over x is short leg to long leg. So then short leg to long leg would be what? 2 over 3. So x is equal to, yeah, 4.5. 9 halves. Is everybody good on that? Now, the reason why I think 4.5 or 9 halves, it doesn't matter, because then we have z is what? Yeah, we automatically know z is 6.5. Now, I would like everybody to just look up there and say y is obviously the square root of 13, right? How did I get that so fast? Very good. I did a squared plus b squared equals c squared. Listen to me. Listen now. Again, I always tell kids, do it the easy way. Right, we all know a squared plus b squared equals c squared. Does everybody remember that? Yep, exactly. So 2 squared plus 3 squared equals y squared.
For the other triangle, we do 4.5 squared.
Yeah, so many ways you can do it. So many ways. All right. All right, let's move on. Here we go. Number 9. I want, here we might have some issues. All right. So I could say z. Okay, so listen, realistically, I don't really care about number 10, but I would like everybody to try the second worksheet. All right, you don't have to do the third worksheet, so just do the middle worksheet, please. Okay. Am I good on that?